Okay, so I'll take a look at this once I'm done with the announcements and the like. So let's talk about the latest homework. Again, I will grade your assignment. I'll grade your exams this week at some point. Not tonight because today's my birthday, and I reserve the right not to. Oh, thanks. So I reserve the right not to do any work when I get home. So, yeah. So, let's see. So sorting algorithms. Okay. This one isn't necessarily too bad. Right. So if you haven't seen it yet, you got to implement insertion sort, quick sort, and one of the other following below, which is either shell sort, merge sort, heap sort, or tim sort, which tim sort will be 7 points of extra credit. Tim sort is kind of a combination of insertion sort plus merge sort. It is currently one of the de facto built-in algorithms that is used by programming languages. The other is some variation of quicksort. For instance, Java uses a two pivot quicksort for sorting primitives. So what you're going to be collecting are lots of data on sorting algorithms. And let me specify that basically what you want to do is you want to generate random arrays of various sizes, from very small to very large, so that you can see the curve of either n squared or n log n. Right? So what I mean by that is, like, it will be very useful if, let's see, sorting example. All right, so what I would do for this is, first off, I would create this function, public static void generate. We can either generate a list or an array, depending on how you want to do this. I figure I'll do array. Generate int array, because we can generate numbers that way, or generate, yeah. Generate array of nums. And what we'll do here is basically, we'll say int size, right? So that's the size of the array I'd like to generate, okay? Now we'll need random for this, so I will simply do random is equal to, so random is equal to new random. Now here's the thing, you can actually provide this so again, this is pseudo random, but one of the things that's fun about randomness is that you can provide it what's called a seed, which is the starting point, not like the starting number, but basically the starting kind of arguments for generating random numbers. So if you provided a seed and you provide the same seed each time, it will give you the same numbers each time, right? So this is useful if you want reproducible results. Otherwise, you leave it blank and it's going to try to figure it out based on some stuff like the current time. But what we want to do now is we'll create a new integer array, right? Int array is equal to new array. Wait, no, sorry. Why did I forget how we do arrays? Because I always do. All right, int array size, right? So we created a new array that's a bunch of zeros. That's very uninteresting to sort. So let's go ahead and generate random numbers. So what we're going to do now is for I in 0 is equal to 0, I is less than array.length, right? What we'll do is we'll say array, the ith item in an array is equal to random dot next int, which will give you a random integer, right? So, and now we just can, and now we can return R, like we're some pirate or something, okay? So now that we've got that right, the idea here is that if you're going to test your public static void main string args, if you're going to test this, then basically what I want to do is test it on sizes of array that are powers of 2. So I might, when I'm testing it, and collecting data, it might look something like this. 4 int I is equal to 0, not 0, but let's start with, let's see, 2 to the 5th and maybe 2 to the 10th, right? So what we'll do there is we will do that. And then what is 2 to the 10th anyway? No, it's 2 to the, so it's not that big. Okay, so and then we'll do is we will say int. So int size is equal to math.pow I to the 2 to the ith power. Okay, which will give me a double. So we're going to go ahead and cast that to an int and turn it into an int so that we can deal with it that way. And then we're going to generate an array that size. Is equal to generate array of nums size. Make sense? So that gives us the array that we can test on, an array we can test on. Now, then what I like, you might find useful is that basically, let me go ahead and I'll create a private class here. Private static class. This is a very easy class that we're going to write. It's more like a struct. Data, which represents a data object. What the heck is a data object? It's going to contain 2 things. It's going to contain int comparisons is equal to 0. Int exchanges is equal to 0. So you could make them static variables, right? I'm sure a lot of you have made the keeping track of your static variables and the like, you know, keeping track of comparisons and exchanges, static variables, but that means you can only keep track of one at a time. So this way I can keep track of multiples by creating multiple objects like this that just hold them. And then my sorting algorithm method, I'll change that basically because, and I'll basically public static data sort int. All right, remember the array gets sorted. So I'll just return new data, which anyway, that's just simply so that it compiles, okay? But the idea here, given your sorting algorithm, it takes in the array of data, it modifies that array. Okay, that's the big point. It modifies the array, so there's no need to return an array, turn that in. Another thing you might need to do for recursive methods is that, like this, public static data recursive sort recursive sort int array, right? And that's going to return when the way that would work, like for quick sort or merge sort specifically, is that if you're trying to keep track of the data, you might do something like this. Data is equal to data D is equal to new data. So we create the data. And then what we're going to do is we're going to return recursive sort int R and then D, not int R, sorry. The array and then the data parameter. And so we'll create and because your recursive sort may need to return something else, like a partial array or something, depending on how you're doing it, then we can just simply have, we can provide the data as an argument here. so that it's shared between all the recursive calls. Right? If we share it as a parameter, then it's shared between it's shared between all those recursive calls. Make sense? So that's one way to keep track of data if you're using an object. Now, the reason I do it like that is because, right, so I get my data object back from sort in the main, okay? But if I want to like run averages of something, I can do that like this. For I want to do 10 of these, right? And now I've done 10 runs of this, and I can say list of data is equal to list of data list is equal to new array list. Sorry, no, I'm not going to call data list. I'm going to call it results because that's what they are. They are results. Okay, so, and now I can just simply say results dot add d. And now, once I'm done with all these generating, figuring out the run times for each run of this, I can now average them, right? And get more accurate data. Does that make sense to everybody? So see how I've got kind of two loops going on here for collecting data. The first loop, why are you giving me issues? Oh, return recursive sort. Oh, I don't need to return anything there. Okay, now it's configured. Okay, so I've got two over here. The first loop basically said, this outer loop says basically this is the size of the arrays I'm going to work with. And this inner loop generates an array and figures out how long it runs. And then over here, I can compute the average for that sorting algorithm on that size, right? So I can collect a lot of data that way. Does that make sense to everybody? So that is a way to manage this so that you can get, actual results. So the idea here is once you collect so again, the idea here is that you implement these sorting algorithms, and feel free to do so by, finding actual implementations of them online and copying them and then modifying them, so long as you cite where you got your original source code from. Okay. And then you got to present your data, which is that I suggest a graph, which is like doing 3 graphs, which is sample size over time, right? So the x-axis is the size of your graph, and the x-axis is the size, and the y-axis is the amount of time that algorithm took. So, for instance, right, if I'm graphing insertion sort, then I'd expect to see, ooh, they changed it. Okay. Then I'd expect to see something like this for insertion sort, where we have n is the size of the graph, size of the array, and then we have time. And it should look something like this, that as n goes up, we get a quadratic relationship, right? And that's just for insertion sort. And so you would have 3 of those showing me basically that, hey, that we've got, these points on powers of 2, which will get progressively further away from each other. So, all right. Any questions on that one? Again, you can do this in any programming language you want. The rest of the semester, you're free to work in any programming language. So if you want to get practice in some language, or another, feel free to do so. All right. Stop share, stop recording.